the following question. Find del W, del R, and del W, del theta using the appropriate chain rule. So we have the A part, W is equal to S squared minus 2xy plus y cubed. We have the S equal to R plus theta, Y equal to R minus theta. So we have the B, we have the C, and we have the D. So we're going to take them one after the other. So the first one, let's do the chain rule. The W is a function of two variables. Okay, so the two diagram will be this, and this one is a function of this and this. This one also is a function of R theta. That's a tree diagram to put here. F is functions of x and y. So we can get the partial derivative of f respect to x, which I'm going to call del f del x. Allow me to use that, get the same thing. And that will be equal to 2x. Differentiate s squared, that's 2x. Differentiate this one partially respect to x. Then we are keeping y constants. That's minus 2y. You are only differentiating this one. All that's are constants. And then plus what? Plus 0. And then can we also get w subscript y, which is simple as what? Del f, del y. Respect to y, this will be 0. This one you are only differentiating y. You have minus 2x plus 3y squared. Don't forget the root of differentiation, ddx of this. If you want to differentiate that, it's going to give you what? The power will come to the front, then the function again, the power of that function minus 1. If you have ddx of maybe 4x equal 3, so it's going to be what? It's going to be equal to this one times this one, that's 12. Then the power minus 1, that's 2. So that's that on how to differentiate. Is a function of r del s del r will be equal to what? That will be equal to 1. Differentiate partially respect to r. So this is 0. So that's 1. Del theta, that's also 1. Do the same thing for y. Del y, del r, that's 1. And del y, del theta, that's minus 1. So we've gotten the necessary equations. Then we can quickly go to what we are told to find, del w, del r, and that will be equal to, you start from here, that's del f, which is simple as del w, del x, and then times what you have here, del x, then what? Del r. Then plus del f, del y, times del y, times over what? Over del f, del x, del f, del x, that's 2x minus 2y, times what? Del x, del r, times 1, then plus del f, del y is what? Times del y, del r, also 1. So that's what we have there. So if you like, you can open the brackets. So we have this. So this one and this one cancel. Then plus this. So it's giving us plus 3y squared minus 2y. Can we also do the del w, del theta? So let's do the substitution. Del f, del x, del x, we have 2x minus 2y times del x, del theta. That's also what? That's 1. Partial differential of f respect to y, or which is what? Minus 2x plus 3y squared times partial differential of y respect to theta, that's minus 1. And you can do the algebra, and that will give you, we have this one and this one, that's 4x minus 2y minus 3 minus 3y squared. Parts. we have w equal to arctan y over x, and then x is equal to r cos theta, y is equal to r sin theta. So the first thing we do, since we know that w is a function of two variables, then that means we are going to differentiate this one respect to any, and we are going to find also that function respect to y. So we need to find del f del x. That will be equal to what? If we differentiate this function, it's going to be 1 over 1 plus this over this of square, and then times del x of the inner function. Okay, don't forget, when you differentiate arctan, dx of arctan, it's going to be 1 over 1 plus a square of this function, the square of the inner function, and that's what we have done there. But in this case now, it involves a chain rule. Okay, it involves a chain rule, and that's why we said times partial differential of that inner functions. Okay, if this case is now is arctan 3x, for example, okay, the derivative of that is going to be very simple. It's going to be 1 over 1 plus the inner function square, and then times ddx. This is going to be ddx because it's a one function here of what? Of the inner function. Okay, but here is multiple variable. There's going to be partial derivative respect to that function. Okay, and this one will now give you, if you differentiate this one respect to x now, you need to rewrite this one like this. Take this one, you are keeping your y constant, you're only differentiating x. That is when you are differentiating partially. Okay, this power will come to the front, you have minus 1, you keep your y constant, and this one again, the power minus 1 minus y over x squared. And don't forget, to do the algebra of this one, which will be 1 plus y squared, that is going to give you x squared plus y squared over s squared. And there is 1 here on top of it. It's going to flip it upside down. You're going to down, and that will be what? That will be x squared over what? S squared plus y squared. So this one and this one cancel. We have minus y over x squared plus y squared. That's for del f del x. You also get this one, differentiate this one. That's a partial differential of this function respect to r. Why what? That's cos theta. Keep this one constant, differentiate this. So get this one, do this one also, differentiate it respect to theta. If you differentiate that respect to theta, it's going to give you what? You are differentiating, and that'll be what? Minus r sine y. So then the next thing to do now is to do the del f del y of this function respect to y, which will be the same thing, 1 over 1 plus y over x, and then you square that times del y of the inner function So in that case now, this one is going to give you del f del y equal to, if you do the algebra of this, it's going to give you f squared over what? Over this. I mean everything here. If you do the algebra of that, then here, respect to y, you only differentiate the y function, you keep the other variable constants. And that's what times 1 over what? 1 over x. Okay? So in that case now, this one we cancel, this one we cancel. The main one here. So we have this over what? Over this. So then the next thing to do now, we need to get del y, del r, which is what? Sine theta, del y, del theta, which is r cos theta. Okay, so let's now get what we are being told to find, the w del r, which is what? Which is this, del f del x, which is the same thing as what? Del w del x, and then times where you stop here, you start at the top here, over what you have here. You differentiate your w also respect to y, which is del f del y times del y del r. So let's substitute what we have. Del f del x we have, then del x del r, which is what? Cos theta, then plus del f del y times del y del r, which is what? Which is sine theta. So we can do the algebra. So in this case now, the denominator is the same. So we're going to have x squared plus y squared. And let's put the positive forward. That will be x sine theta. And then minus what? Minus y cos theta. So the next thing to do now is del W del theta, which is this equation. That's what we have here. Let's quickly substitute that and get the equation for del W del theta. Del W del theta, del F del X del F del X. I have the value for that. Del X del theta, then plus del F del Y. I have value for that, which is this del Y del theta. That's r cos theta. So then do the algebra, and that will be equal to, the denominator is the same. So we're going to have minus times minus. So we're going to have take over this. So, and that's that for the second case, and that's the end of B question. So please, if you're watching me for the first time, quickly smash the watermarks on this video and subscribe. Okay. At the same time, also click on like button and begin to type your comments. Make this section interactive. Finally, share the links of this video on all your social media platforms. Thank you for doing that. You can book your place for one-on-one or group discussion on either Calculus 1, Calculus 2, Calculus 3, Calculus 4, or any other personal assistance. Thank you for doing that.